Okay, so welcome back. Now in this video we're going to talk about continuous growth and decay. So in general, when we look at continuous growth or decay, we are going to use this formula here. And again, this is E, the exponential E, the natural exponential. A represents the initial value, the initial amount. And then we have R, which represents the continuous percentage rate per unit time, okay? And then T represents time, okay? And then of course A is the future value, the accumulated amount, the ending amount, right? So this is the amount you have. Now this could be related to anything that has continuous counting or close, that can be considered continuous growth or continuous decay, okay? So depends on the situation. Now, the thing is if the rate is positive, if this is a positive rate, okay, if R is positive, then it's going to be a growth, exponential growth. If R is negative, then it's going to be exponential decay. Okay, so it's going to be continuous. If R is positive, it's continuous growth. If R is negative, then it's going to be continuous decay. Okay, so now in the realm of finances, though, when you're talking about investments, loans, and things like that, and you're talking about continuous growth on a loan or on an investment, then it would look like this: A of T equals P e to the RT, where P is the principal, right? I like to use PERT, P-E-R-T. Okay, so P is the principal amount, R is the rate, right? The continuous rate, right? And then T is just time, and again that's usually given in years. It's the annual, it's the number of years. Okay? And so now here's the thing. The interest rate, again, per unit time, so whatever this is, has to equal this. So if T, now technically if T could be measured in months, but then the rate has to be a monthly rate, not an annual rate. Okay? So if this is an annual rate and T is given in months, then you have to convert T from months to years. So be careful about that, okay? So be careful. But this is the formula that we would use. So, for example, let's say we have a person invested $1,000 in an account earning a nominal 10% per year compounded continuously. Okay, so there's the key word, continuously. So we know we have to use this continuous compounding formula. How much was in the account at the end of 1 year? So, okay, so again, the principal is $1,000. So P equals $1,000. Okay, the rate is a 10% rate. Now, here's the thing, it's an annual percentage rate per year. So it says per year. So R is equal to 0.10. And it's compounded continuously. And it says how much is at the end of 1 year. So T equals 1 year. Okay, 1. So now all we have to do is plug and chug. Okay, so it's going to be $1,000 times E to the 0.1 times 1, of course, so that's going to be 0.1. And so what would this be approximately equal to? Well, we're going to get approximately $1,105.17. Okay, so we'll earn about $105 in interest in 1 year. Okay, now what about this one? Let's say a person invests $100,000 at a nominal rate of 12% interest per year, compounded continuously. What will be the value of the account of the investment of 30 years? I love this one. Okay, so in this case here, they're investing $100,000, so P is $100,000, and it's compounded continuously. And R is a 12%, oops, not $12, is a 12% interest rate, so it's going to be 0.12. And it's invested for 30 years. 30 years, so T is 30 years. Okay, again, this is an annual interest rate, so T has to be in the number of years, which we know is 30. Well, how much money is going to be in there? Well, let's find out. So we're going to use A equals P times e to the RT. Excuse me. So this is going to be 100,000 times e to the 0.12 times 30. Okay, now, all we have to do is plug this into our calculator. And what do we get? We get, hold on. So you'll have, oh, this is good. You'll have 3.659, so I'll round to the nearest dollar. So you'll have 3.659. So you'll have about $3.6 million. Okay, if you round it to the nearest dollar, okay, or to the nearest penny. Okay, so you'll have over $3.6 million in the bank if you were able to invest $100,000 over a 30-year period. And if you were able to get it for tax-free, that'd be awesome. Now here's the thing. This is realistic. I mean, the stock market, just incidentally, the stock market over the last 90 years, 90 plus years, has averaged, I think for my last time looking at, about 13% a year since inception. So for 90 years, that includes the Great Depression, all the recessions, the market corrections, all the way up to today, it's between 12 and 13% is what it's averaged. So, nothing to be afraid of if you keep your money in there over a long period of time. Okay, that's it. Have a great day.